Everyone. Today, the topic which we are going to cover is PERT and CPM, that is Project Evaluation and Review Technique, and CPM is Critical Path Method. So, let us first try to understand that why do we need these networking techniques. So, any project is composed of various interrelated activities. So there are a number of activities which are there in a project, and it is necessary to perform these activities in a sequence. So it is natural to estimate accurately the cost and time involved in the implementation of various activities so that the resources can be utilized up to an optimal level and the project can be completed in a predetermined time period at estimated cost. So, in nutshell, we can say that PERT and CPM basically helps the operation manager to complete the whole task in a predetermined time and cost. But other than this, what we can do out of PERT and CPM is we can also reduce the overall cost and time of the whole project so that we can efficiently use our resources. So the process with which we can reduce the overall cost and time of the project is called crashing. So in today's lecture, we are going to study the process of crashing. So let us move forward. So here is the question we have. So what we have done is we have divided the whole task into different activities as you can see here. So here we have different activities, say for example, activity 1 to 2, 1 to 3, 2 to 4, 3 to 5, and so on. In next column, we are given time. So there are two times, normal time and crash time. So normal time is the time which is required to complete an activity. That is to complete 1 to 2 activity, the normal time required is 8 weeks. But if I want to complete this activity in less than weeks, so here we have crash time. So crash time is if I want to complete the activity in the lesser time period, what would be the minimum time period in which I can complete this activity? So here it is given 4. So as you can see, there is also a normal time and crash time given for the same activity. If I want to complete this activity in 8 weeks, the cost required would be 3,000. And if I want to complete the same activity in lesser time period, that is 4 weeks, then the cost would be 6,000. So similarly, we are given normal time and crash time and normal cost and crash cost for all the activities. So as you can see for 1, 2, 3, the normal time is 5 and crash time is 3. So here you can see that if I want to complete the activity in 5 weeks, the cost would be 4,000, and if I want to complete the activity in 3 weeks, the cost is 8,000. So if you want to complete an activity in lesser duration, then you have to increase the cost. So these are the different time and cost trade-offs given to you in the question. Now, my whole purpose is to reduce the time and cost of the whole production process. For this, the first thing I have to calculate is cost to expedite per week. So to calculate cost to expedite per week, or we can say slope of the activity, the formula is crash cost minus normal cost divided by normal time minus crash time. So this is the formula to calculate cost to expedite per week of or the slope of the activity. So with this formula we can calculate all these slopes for all the activities. So here we can do this. So now I have calculated the slope of all the activities with the help of this formula as you can see here. Before moving forward, there is an additional information given in the question, that is the activities duration and the direct cost of the project is given below, and the indirect cost is rupees 2000 per week. So the cost is 2000 per week given for each week, which is not included here. We have to consider this 2000 rupees later on when we'll do the final calculations, and we'll see how we are going to do that. So moving forward, the next thing we have to do is we have to calculate the total of normal and crash cost, which is given here. So the total of normal cost is 45,200 and the total of crash cost is 71,100, which is given in the question. So now we will make the network. So here you can see the activities. Now we will make the network. Let's see how we are going to do this. So first activity is 1 to 2. So here we can create the network from 1 to 2 like this. This is 1, this is 2. Then there is 1 to 3. So next is 1 to 3. Then 2 to 4. 2 to 4. Then there is 3 to 5. 3 to 5. Then we have 2 to 5. So we'll join 2 to 5. So we can make these arrows so that we'll understand that we are moving from 2 to 4 or 2 to 5. Then there is 4 to 6. So here it is 4 to 6. Then there is 5 to 6. 5 to 6. Then 6 to 7. Like this. Then 5 to 7. So this is the network which we have created. Now we'll divide each event. So 1 and 2 is event and this row is called the activity. So an activity is completed when we start with an event and end with an event. Okay, so we'll divide each event in two parts. So the first half is called EOT, which is earliest occurring time, and the second half is called LOT, which is latest occurring time. So here EOT stands for earliest occurring time, which means if we'll start the activity at the earliest, what would be the time? And latest occurring time is even if we'll get delayed, how much delay is allowed. So for each activity, we have two time slots, EOT and LOT. So we'll divide all the activities in two parts, EOT and LOT. Now moving forward, in the question you were given the normal cost of all the activities, which we can see in the question here. So here you are given all the normal times, which is given here. So these time slots I will plot on the network. So moving forward, so here I'm going to write all the normal times which were given in the question on the network. So for 1 to 2, the time was given 8 weeks. For 1 to 3, the time was 5. For 2 to 4, time was 9. 3 to 5, 7. 2 to 5, it's 5. Then there is 4 to 6, 3. Then there was 5 to 6, 6. 6 to 7, 10. And 5 to 7, 9. So here it is given. Now we'll start to calculate the total time required to complete an activity, to complete the whole process. So activity 1 to 2. So this activity starts with a 0. So 0 plus 8. This 0 plus this 8. EOT of the first activity plus the duration. EOT of I, which is 1, plus the duration of ij becomes EOT of j. So ij here is activity 1 to 2. So 0 plus, so here 0 plus 8 is 8. So I'm going to write it here. Then 0 plus 5, 5 here. I'm applying the same formula, this one. This 8 plus 9 is 17. Now, to reach 5, I have two ways. Either I can come from 2 to 5 or from 3 to 5. But I will choose the longest one. So 8 plus 5 is 13 and 5 plus 7 is 12. So I will choose the longest one, that is 13. So why I'm choosing the longest one? As you can see that 2 to 5 and 3 to 5 are simultaneous activity. Even if I'll complete 3 to 5, I have to wait for 2 to 5 to get completed, else I cannot move from 5. That's why I'm choosing the longest path, that is 8 to 5 and 13. Now again, to move to 6, I have two ways, from 4 to 6 or 5 to 6. Again, I will choose the longest path, that is 17 plus 3, 20, or 13 plus 6, 19. So I will choose the longest one, that is 20. Now to reach 7, again I have two ways, that is 5 to 7 or 6 to 7. From 5 to 7, there is 13 plus 9, it comes to 22, and 6 to 7, 20 plus 10, 30. So here I'm writing 30. Now I have reached my final activity, that is 7, and the duration is 30. Now I will move backward. To move backward, the EOT of last activity is also the LOT of last activity. So here I'm writing 30. Now I will move backward. To move backward, the equation will be a bit different. So here what I'll do, I'll subtract instead of adding. Earlier what I was doing is I was adding the EOT of the first activity with the duration, but here I will move backward and I will deduct. So what I'll deduct, the LOT of the previous activity minus the duration of the activity. So what we will get, LOT of I. So this is the formula. So this 30 LOT of j minus duration of ij, that is 10, and I will get LOT of I, that is this 20. So now point is, now I have to move to 5. To reach 5, I have two ways. Either I can come from 6 or by 7. So here I will choose the shortest way because I'm moving backward, right? So now 20 minus 6 is 14, and 30 minus 9 is 21. So here I will choose the shortest path. So 20 minus 6, 14, I will pick. Now there is one more question, why I have started like this, 7 to 6, why not 7 to 5? So here keep in mind that whenever you are going with backward movement, always come to immediate preceding activity, that is 6. 6 is the immediate preceding activity of 7, not 5. So you first you have to go to the immediate preceding, then you can move to 5. So now I'll move from 6 to 4, 20 minus 3, 17. And to move to 2, we have two ways. From 5 I can go, or from 4 I can go. So I will choose the shortest one. So 17 minus 9 is 8, and 14 minus 5 is 9. So I will choose the shortest one, that is 8. Now 5 to 3, 14 minus 7 is 7. Now I will be at the first activity, that is 1. So 8 minus 8, 0, and 7 minus 5, 2. So again I will choose the smallest one, that is 8 minus 8, 0. So here we are done with our first network. Now what next I have to do is I have to find the critical path. To find the critical path, we call it we have to calculate a term called slack. So here I have to calculate slack of each activity. The formula to calculate slack is LOT minus EOT. So I will calculate slack of all the activities, which I'm writing here. 0 minus 0, 0. 8 minus 8, 0. 7 minus 5, 2. 14 minus 13 is 1. Then 17 minus 17, 0. 20 minus 20, 0. And 30 minus 30, 0. So as you can see, there are some activities whose slack are 0. So the activities which are having slack as 0 are the critical activities, because there is no delay allowed in these activities. As you can see in activity 3, here the slack is 2. It means 2 weeks delay is allowed. But there are certain activities like 1, 2, like 1, 2, 4, 7, 6 and 7. The slack is 0. It means there is no delay allowed in these activities. So these are critical activities. And from these critical activities, I will find my critical path. So critical path is 1 to 2, 2 to 4, 4 to 6 and 6 to 7. So this is our critical path. Now moving forward, if you remember, we have calculated the cost to expedite per week at the start of the question. Now I'm going to write the cost per week here of all the activities of critical path. So the cost per week for 1 to 2 is 750. Then second 2 to 4 is 500. Then 4 to 6 it is 2400, and 6 to 7 it is 900. So these are the cost per week of critical path. So as you can see, if I will crash the activity 2 to 4, the cost per week is minimum in this case. So what I'm going to do next is I'm going to crash this activity 2 to 4. So crashing, what does crashing mean? Crashing means I'm going to change the normal time to crash time. So what I have done is I have doubled this line. So double line is a symbol that I have crashed this activity, and instead of 9 I will write its crash time. The crash time of this activity 2 to 4 is 6. So what I'm going to do is I'm going to write 6 here. So as I have written 6 here, I have to prepare the whole network again. So this is quite a lengthy process. So now moving forward, I will make the network again. So before moving to the next diagram, the next network basically. So we have prepared a table here where The headings I have mentioned is activities crashed, project duration, total cost, total indirect cost, and total cost. So the first network which we have created, we didn't crashed any activity. So here we'll write none. The project duration in the first network was 30, the final one. Then the total indirect cost would be the total of the normal cost, which is given in the question. This is 45,200. So I'll write 45,200 here. So total indirect cost given here is as if you remember in question we mentioned that there is an indirect cost of 2000 per week, so 30 weeks duration, so the total indirect cost is 30 into 2, which comes to 60,000. So here the total cost is 45,200 plus 60,000, it is 1,05,200. So likewise we will mention all the changes in this table, right? So now we are moving forward with the second set of network. So here we are with our second set of network where I have crashed 2 to 4 and I have changed this time from 9 to 6, from normal time to crash time. So again I'm going to follow the same rules. So here 0, 0 plus 8 is 8, 0 plus 8 is 8, 0 plus 5 is 5, 8 plus 6 is 14, and 5 plus 7 and 8 plus 5, again we'll take the larger one, that is 13. Now this is 14. 14 plus the normal cost of 4 to 6 is 3. So 14 plus 3 is 17 and 13 plus 6 is 19. So we'll take the larger one, 19. 19 plus 10 is 29 and 13 plus 9 is 22. So we'll take the larger one, 29. So EOT of last activity is again 29. 29 minus 10 is 20. Sorry, 29 minus 10 is 19. So here I'm going to write 19. Here it is 19. 19 minus now 5. 29 minus 9 is 20 and 19 minus 3 is 13. So I will take the smaller one. So now 19 minus 3 is 16 and for 2, 16 minus 6 is 10 and 13 minus 5 is 8. So I'll write 8. So here 13 minus 2 is 11. 8 minus 8 is 0. Whether 11 minus 5 is 6. So I'll take 0. So here we are done with the second set of network. So we'll calculate slack of all the activities. So 0 minus 0 is 0. 8 minus 8 is 0. Now 14 minus 16 minus 14 is 2. 13 minus 13 is 0. 19 minus 19 0 and 29 minus 29 is 0. So here the new critical path is 1 to 2, 2 to 5, 5 to 6 and 6 to 7. Now I will write the cost per week of all the activities of critical path. So for 1 to 2 the cost per week is 750. Now 2 to 5, for 2 to 5 the cost per week is 1000. Then 5 to 6, for 5 to 6 cost per week is 700. And for 6 to 7 the cost per week is 900. So the smallest one here is 5 to 6. So the next activity I'm going to crash is 5 to 6. So 5 to 6 is this. So I am going to crash this. So I'll make it a double line, and instead of 6 the new crash time is 2. So instead of 6, I'm going to write 2 here. So again, I'm going to make a network, and before that, what I'll do is I'll update my cost sheet. So here the activity which I have crashed is in the second network, that is 2 to 4, and the duration now is 29. Now the total direct cost. So the total direct cost we'll calculate as we have crashed the activity 2 to 4. We'll see what is the difference between the normal cost and crash cost of 2 to 4. So the difference is 1500. So what I'm going to do is I'm going to add 1500 to 45,200. So by adding 1500 to 45,200, it will become 46,700 like this, and 29 week into 2000, so it becomes 58,000, and the total cost is 1,04,700 like this. So now I will prepare my third network. So the activity now which I have crashed is 5 to 6. So already I'm writing here 5 to 6, and I'll calculate project duration, total cost, indirect cost, and total cost. So now I'm moving forward. So here we are with the next set of diagram. So here we are with the third set of network. So now again we'll make the network 0 plus 8, 0 plus 5, 5, 8 plus 6, 14, and for here 5, again we'll take the larger one, that is 13, 8 plus 6, 14. Now 14 plus 3, 17, and 13 plus 2, 15. So I'll take the larger one, 17. 17 plus 10, 27, and 13 plus 9, 22. So I'm going to take 27. So 27 minus 10 is 17. So here 17 minus 2 is 15, and 27 minus 9 is 18. So again I'm going to take the smaller one. So 17 minus 2 is 15. 17 minus 3 is 14. Then 14 minus 6 is 8, and 15 minus 5 is 10. So I will take the smaller one, that is 14 minus 6, 8. 8 minus 8, 0. Here 15 minus 7 is 8. So now again we'll calculate the slack of each activity. So here 0. 8 minus 8, 0. 3, 2, 0, 0, and 0. Now I will see the critical path 1 to 2, 2 to 6, 6 to 2 to 4, 2 to 4, 4 to 6, and 6 to 7. Again I will write the cost per week of all the activities of the critical path. So the cost per week of 1 to 2 is 750. 2 to 4 is 500. 4 to 6 it is 2400, and for 6 to 7 it is 900. So now the minimum cost per week is 2 to 4, which is 500, but this activity we have already crashed, so we'll take the next minimum cost per week, that is 1 to 2. So the next activity I'm going to crash is 1 to 2. So here the double line. So instead of 8, I will write the crash time of this activity, that is 4. So here it is 4. Now again, I will make the network. Before that, I'll update my cost sheet. So moving forward, here we are. So by crashing 5 to 6 activity, the new duration is 27. Now, what was the additional cost for 5 to 6? From 4,000, it was supposed to be 6,800. It means 2,800 more. So I will add this 2,800 to 46,700. So it comes to 49,500. And the indirect cost is 27 into 2000, so it comes to 54,000, like this, and the total cost is 1,03,500. Now I will make the third set of network, and before that the activity which I have crashed just now is 1 to 2. So I'll see what would be the project duration and the total cost after crashing 1 to 2. Now moving forward. So now I'm going to start next set of network. So here 0, 0 plus 4 is 4, 0 plus 5 is 5, then 5 plus 7 is 12, and 4 plus 5 is 9. So I'll take the larger one, that is 12. 4 plus 6 is 10. So here 10. Then 12 plus 2 is 14. And 10 plus 3 is 13. So I'll take the larger one, 14. 14 plus 10 is 24. Here 12 plus 9 is 21. So I have taken the larger one. So this is 24. 24 minus 10 is 14. Now 14 minus 2 is 12, and 24 minus 9 is obviously larger than 12, 13. So here 12. 14 minus 3 is 11. Here 11 minus 6 is 5, and 12 minus 5 is 7. And so I will take the smaller one, that is 5. So I will not take 7 here. So here it is 11 minus 6, which is 5. Now 12 minus 7 is 5, and 5 minus 5 is 0. So the new critical path is 1, 2, 3. So 0, as we have calculated the slack, 0, here 0, 0, 0, 1, 1. So the new critical path is 1 to 3, 3 to 5, 5 to 6, and 6 to 7. Now I will write its cost per week. So 1 to 3, the cost per week is 2,000. 3 to 5, the cost per week is 950. 5 to 6, the cost per week is 700. And then 6 to 7, the cost per week is for 5 to 6, the cost per week is 700, and 6 to 7, the cost per week is 900. So again, I'll pick the smallest one. So the smallest one is 5 to 6, but it is already crashed. So the next smallest one is 6 to 7. So now I'm going to crash 6 to 7 here. So to crash 6 to 7, I will make a double line here, and the crash time will be from 10, it is 7. So instead of 10, I will write 7 here, and again I'm going to update my cost sheet. So now by crashing 1 to 2, the new duration is 24. Okay. Here I'm going to write 24. Now by crashing 1 to 2, how much extra expenses I have to bear? I can see from here 3,000. 3,000, 6,000, so 3,000 extra. So I will add this 3,000 to 49,500. So it will become 52,500. And the indirect cost, 24 into 2,000, which comes to 48,000 here. And the total cost is 1,500,000 here. Now moving forward to the network. So now I'm going to make next set of network here. 0 plus 4, 4. Okay. 4. 0 plus 5, 5. 4 plus 5 is 9 and 5 plus 7 is 12. Then 4 plus 6 is 10. 10 plus 3 is 13 and 12 plus 2 is 14. And 14 plus 7 is 21 and 12 plus 9 is 21. So here we are, 21. 21 minus 7 is 14. 14 minus 2 is 12. 14 minus 3 is 11. And 11 minus 6 is 5 and 12 minus 5 is 7. So I'll write 6 here. Sorry, 5 here. Here it is 5. Then 12 minus 7 is 5. 5 minus 5 is 0. So now the critical path is 1 to 3, 3 to 5, 5 to 6 and 6 to 7. So the cost per week for these activities is 1 to 3, 2,000, 3 to 5, it is 950, 5 to 6, it is 700, and 6 to 7 it is 900. So 5 to 6 and 6 to 7 we have already crashed. So now we are left with 3 to 5, which is 950. So the next activity which I'm going to crash is 3 to 5. So now I will change this normal cost to crash cost. So from 7 it will be 5 now. Now it's time to update the cost sheet. Now move forward to that. So here we are. The activity which we have crashed in this network is 6 to 7. So now the new time is 21. Now we have to see what is the extra cost we have to incur to crash this activity. So we'll move to 6 to 7. Here we are. So it is 2,700 more. So I'll add 2,700 here. So it becomes 55,200. Now 21 into 2,000, it comes to 42,000, and the total here is 97,200. Now we'll move back to the network. So now again with the network 0, 0 plus 4, 4, 0 plus 5, 5, then 4 plus 6 is 10, but okay. Now for 5, 5 plus 5, 10, 4 plus 5, 9. So I'll write the larger one. So here we are, 10 plus 3, 13 and 10 plus 2, 12. So I'll write 13. So here 13 plus 7, 20. We'll write 20 here, and 10 plus 9 is 19. So I have taken the larger one, 20. 20 minus 7 is 13. 13 minus 2 is 11 and 20 minus 9 is 11. 13 minus 3 is 10. 11 minus 5 is 6 and 10 minus 6 is 4. And 11 minus 5 is 6. 4 minus 4 is 0. So here we are. The new critical path is 1 to 2, 2 to 4. 4 to 6 and 6 to 7. I'll write cost per week of all the activities here. So the cost per week for 1 to 2 is 750. 2 to 4 it is 500. 4 to 6 it is 2,400. And then 6 to 7 it is 900. Now as you can see that here we have already crashed almost all the activities. So here the only activity left is 4 to 6. We have crashed 1 to 2, we have crashed 2 to 4, we have crashed 6 to 7, so we are left with 4 to 6 only. So we'll crash this activity. So by crashing 4 to 6, the new time is 2.5. So here I'm writing 2.5. Okay, so I'll move forward to update my cost sheet first. So here I am. The activity which I have crashed here is 3 to 5. The duration has become 20 weeks. Now for to crash 3 to 5, the extra cost which I have to incur is 1900. 3900 minus 2000, 1900. So I'll add this 1900 to 55,200. So it comes 57,100. Here 20 minus 2000, 40,000. And the total cost is 97,100. Okay. So the next activity which I'm going to crash in the next diagram is 4 to 6. So I'm already writing 4 to 6 here. Now let's move forward for the network. So here we are. Okay. 0 plus 4 is 4. 0 plus 5 is 5. Now 5 plus 5, 10. 4 plus 5, 9. So I'm taking the larger one, 10. 4 plus 6, 10. 10 plus 2.5 is 12.5. And so 12.5 plus 7 is 19.5, and 10 plus 9 is 19. So I'm going to write the largest one, 19.5. So the LOT will also be 19.5 here. 19.5 minus 7 is 12.5. 12.5 minus 2 is 12, 10.5, and here 19.5 minus 9 is 10.5. So I will write 10.5 here, and 12.5 minus 2.5 is 10. 10 minus 6 is 4, and 10.5 minus 5 is 5.5. So I have taken the smaller one, and 10.5 minus 5 is 5.5, and 4 minus 4 is 0. So here we are. I'll write the critical path now. 1 to 2, 2 to 4, 4 to 6, and 6 to 7. Now, if you see that this critical path has all the activities which are already crashed. 1 to 2 is crashed here, 2 to 4 is crashed, 4 to 6 is crashed, and 6 to 7 is already crashed. So here we are done with the question, but the final step is to update the cost sheet. So I'm moving forward to update the cost sheet first. So here we are. By crashing 4 to 6, the time is 19.5. Now by crashing 19.5, how much extra cost I have to incur? 4 to 6. Okay. So 4 to 6. Here we are 10,000 and 11,200. It means 1,200 more. So I will add 1,200 to 57,100. So it comes to 58,300 here. Now 19.5 into 2000, it comes to 39,000, and the total is 97,300. Here we are. So now let's see what has happened by following such a long procedure. As you can see that at first point of time, the project duration was 30 weeks. Now by crashing all these activities, we are at 19.5 weeks. So we have reduced the time. And if you see the cost part, here the cost was 1,05,200, and at the end point it is 97,300. So we have reduced time and cost simultaneously. And if you see here in the last 2 points, The cost here is 97,100, but here the cost is 97,300. But the weeks, the time is more here and less here. So it is up to the manager that whether he wants the cost to be the minimum or time to be the minimum. So it depends on his own discretion. So we are done with the question. Thank you very much.